going to step in for, okay. I'm stepping in for Ben Jones today. I am Christina Shado, and I'm based in Flagstaff, Arizona, and I am a co-leader of the Permafrost Collaboration Team as well. So a warming Arctic is increasing the opportunities for agriculture in the subarctic and Arctic, while simultaneously driving the degradation of near-surface permafrost. For the expansion of high-latitude agriculture to be sustainable, research needs to account for the heterogeneity of permafrost, agriculture, and social systems, and include northern farmers. This meeting today will provide an overview of the recently funded Permafrost Grown Project, which has been funded by the National Science Foundation's Navigating the New Arctic program. And Permafrost Grown focuses on co-producing knowledge with Alaskan and Siberian farmers to study the interactions and feedback between agriculture and permafrost. I'm actually very excited about this slightly different approach of topic today, and we have three excellent, hopefully, presenters. First, I'm not sure who's going to go first, but the presenters are Glenna Gannon, who's an assistant professor of sustainable food systems in the Institute of Agriculture, Natural Resources, and Extension at the University of Alaska Fairbanks. Her work focuses on the sustainable development of high-latitude food production and human dimensions of northern food systems. And then we have Melissa Ward-Jones, who is a postdoctoral fellow in the Institute of Northern Engineering, also at the University of Alaska Fairbanks. She's interested in the causes, consequences, and significance of geomorphic change in permafrost systems, and applying her knowledge of permafrost to sustainability topics and issues, such as those related to northern food systems. And then last, we have Iris Sutton, who is the owner of Ice Wedge Art and Farm, established in 2012 in Fairbanks, Alaska. The farm grows vegetables and raises goats and chickens. Iris grew up both in rural and urban Alaska and is a collaborator on the Permafrost Grown Project, and her farm is a primary field site. Yeah, so we will go ahead and have the three presentations, and I would suggest we keep our questions till the very end. Of course, if there is anything clarifying, feel free to add it into the chat box. And I look forward to the presentations. I think Glenna's going first, or is it Melissa?
Screen share. Can you see the screen?
Yes, we can.
Great. So I will just hold on. Oh. Okay. Oops. Go ahead. All right. Thanks, Christina, for the introduction, and everyone for joining us today. Just quickly, I will mention that I'm going to be following my notes a little bit because we have a lot to cover today. And second, I would like to acknowledge and thank the stewardship of the Lower Tanana Dene people upon which, upon whose ancestral territory we are joining from, live, and work on today. All right, so I'm going to be talking a bit about the northward expansion of agriculture and measuring change in agricultural systems in the context of Alaska in particular, and at high latitudes more generally, and for this project. And as Christina mentioned, happy to answer questions beyond, or in specific questions about this question, about my part of the presentation, but after we all present. So to get us started, I'm quickly going to give a broad strokes overview of the Alaska food system and agriculture and food production in Alaska, just to provide some contextualization for our research project. Alaska has a really rich, unique, and diverse food system. We depend on many wild foods, both plant and animal. We are highly dependent on imported foods for our consumption, and there's a growing agriculture sector in the state as well. So for the relationship between agriculture and production and climate change, this is of a particular interest and importance with for the state of Alaska for several reasons, including, as mentioned, the accelerated pace of climate change, Alaska's vulnerability to supply chain disruptions because of our dependence on imported foods, as well as the potential for agriculture expansion. Food security is of particular concern in Alaska for the aforementioned reasons, mostly because of our remoteness from the contiguous United States, as well as other food producing regions of the world. Of all the agriculturally produced food in Alaska, we are consumed in Alaska, excuse me, about 5% of that is grown locally. Alaska also has many communities which are inaccessible by the road system and the rail belt, and this makes them vulnerable to interruptions in supply chains, such as those caused by extreme weather events like earthquakes and tsunamis, as we've seen increasing in the last several years, and most recently the COVID-19 pandemic. So if you see here the rates of food insecurity in much of rural Alaska, these areas off of the transportation line have much higher rates of food insecurity than those in more urban Alaska, and especially when compared to the rates of the rest of the United States, I should say the average rate of the rest of the United States. So one of the solutions to food insecurity and Alaska's vulnerabilities identified by Alaskans and policymakers alike is to produce more food in state. So quickly, a little history of agriculture in Alaska, and this is going to be, again, just very broad strokes. And yes, there is agriculture. So the long view is, Alaska Native people have been producing food for a long time and doing so by managing wild plant and animal species for millennia for increased yields. That includes berries and fish populations. Northern indigenous people have been using Arctic, tundra, and boreal ecosystems to raise, graze, and herd reindeer for hundreds of years and millennia in other parts of the circumpolar north. And Tlingit and Haida on the coast have been cultivating several species of primitive cultivars of potatoes since before European contact. And a primitive cultivar refers simply to the fact that these are not genetically modified or selectively bred cultivars of potato, not that they have anything to do with the people growing them. So in the context of this project, however, we are primarily focused on those production activities involving domesticated agricultural species. The agricultural sector as we know it in Alaska today was largely kickstarted by European and Russian settlers and started to really expand in 1898 with the legislation that extended the Homesteading Act into Alaska prior to statehood. Another major event that really started agriculture for Alaska was the appointment of special agricultural agents, US special agriculture agents, to come to the state to establish agriculture and forestry experiment stations in order to see whether or not agriculture was truly viable for those homesteaders being encouraged to come to Alaska, as well as for military purposes. And so you can see some of the early agricultural endeavors here in the state, including domestication or the attempted domestication of muskox, grains, hay, using large draft animals. We did have many dairies in the state originally, and some examples of agricultural test plots in those agriculture and forestry experiment stations. Also, in sort of the height of the agricultural boom in Alaska in the mid 20th century, it was estimated that as much as 40 to 50% of the food Alaskans consumed was actually produced in state. However, with the cool summers and the long winters, short growing seasons, and extreme frigid temperatures and winters, most farming in Alaska has remained relatively limited by our cold climate. And there have been ebbs and flows in the amount of agricultural production in the state over the years, and remains today, commercial agriculture today remains a relatively small part of Alaska's overall economy. So present day, skipping ahead quite a bit, agriculture production uses about 0.2% of Alaska's 390 or so million acres. And the agricultural sector is dominated by small scale farms ranging in 1 to 9 acres or less in size. That tends to be the typical Alaskan farm. And we do have larger farms as well, but that's really the sort of heart of our agricultural scene. And much like our co-producers, Iris's farm size. There have always been contributions to the collective knowledge of what works and doesn't work by individual innovative farmers and producers in Alaska, as well as academia. And that's really formed and shaped the agriculture of Alaska today. There are certain cold hardy crops that have always been relatively successful in the state, such as potatoes, carrots, cabbage, and some small grains like barley and certain varieties of wheat. These crops have been both the backbone of subsistence gardens and commercial agriculture in the state. However, with the changing climate and innovations that farmers are making, aided by research, there are new developments to Alaska's agricultural scene, especially with things like the addition of the peonies to Alaska's export agricultural market. There's an example of a peony field in the lower left-hand screen there. So these are just some examples of farms in present-day Alaska, and in the case of the upper left-hand, the Agriculture and Forestry Experiment Station here in Fairbanks, and my research plots. And this is an example of a larger scale production. This is about a 1,500 acre farm for barley production in Delta, Alaska, and the associated mill for those barley products. All right, so with these changes, these climatic changes, Alaskan agriculture is experiencing a bit of a growth spurt. And this appears to be the trend for other parts of the circumpolar north as well, largely due to polar amplification, which many of you are probably familiar with, but that's the increase of temperature and warming in the far north at a rate of approximately 3 times that of other places in the world. So based on the most recent US Census of Agriculture done in 2017, that's what these infographics are based on, there's been an increase in the number of new farms in Alaska, an increase in the amount of food sold directly to consumers in the state, and there's a general increase in the number of new farms in Alaska, whereas there is a decreasing trend in the rest of the United States. We also have the highest number of new or beginning farmers in the nation here in Alaska. And so with the world's population continuing to grow and land suitable for agriculture in other regions of the world declining or in productivity or becoming fully exploited, recent literature suggests that places and people may be looking to the north in order to expand agricultural opportunities. Here in Alaska, research has begun to study the effects of climate change and what this might mean for our agricultural scene. Climate modelers at the University of Alaska, Fairbanks International Arctic Research Center predicted that by 2100, the frost-free season will extend not just by days or weeks, but potentially by months, with the cumulative summer heat doubling and the coldest winter days being anywhere from 10 to 15 degrees warmer than they have been historically. And that's represented in these hardiness zone maps, which is a USDA designation of what can grow where in particular regions. And as you can see here, this map for around 2100 indicates a growing climate more akin to that of Washington and the Pacific Northwest. So this means that the realm of possibility for what we can grow in Alaska will be much more like that of more southern latitudes. And perhaps even more significantly is the projected shift in high latitude growing climates for the current and anticipated change in growing degree days. So this is a measurement of the cumulative buildup of daily heat above a crop specific minimum threshold across an entire growing season. And this change in cumulative heat throughout the summer is part of what is making it possible to grow crops that were formerly not not feasible to grow here in Alaska, as represented by sweet corn that you see here. And this is a harvest at the Agriculture and Forestry Experiment Station of sweet corn last year. And what we see here by tracking the growing degree days for sweet corn in Fairbanks in particular is that between 1930 and 2020, there's actually been an almost 60% increase in those growing degree days. So that is a pretty dramatic difference. So other contemporary research that's being done to evaluate how change in Alaska will affect our agricultural systems. So there's researchers with the Scenarios Network for Alaska and Arctic Planning, or SNAP, here at IARC as well. We're using global climate change models downscaled to a local level and coordinating with insights from local farmers to evaluate what climate change might mean for different communities throughout the state. Here's an example of some of the figures that they're producing as part of that research. I, at the Agriculture and Forestry Experiment Station, conduct variety trials to evaluate the success of commercially available plant varieties as well as new plant species, and to evaluate how they're adapted for the growing climate here. Variety selection is arguably one of the most important choices a producer can make in order to have, a crop that is suitable for the growing climate. And then we've also launched a citizen science app, Grow and Tell, where individuals can document their crops and varieties that they have tried to grow, and we aggregate those results to broaden the scope of the crops that we're able to trial here in a formal way at the Agriculture and Forestry Experiment Station. Other researchers within my institute in particular conduct research on small grain production, soils, cover crops, insect pests, and more in order to evaluate Alaska's changing agricultural scenarios. And we are also in the process of hiring a plant geneticist to reestablish a plant breeding program here at UAF in order to develop cultivars that are specifically bred to thrive in Alaska's specific conditions. And there's much more research going on within the state. That's just sort of a broad overview of those things, again, within my institute and here at UAF that are contributing to how we are looking at the changing climate in respect to climate change. So since agricultural activity was established in Alaska, interactions between permafrost and production activities have been present. And this triggers structural changes in frozen ground. And here's a perfect example of actually a field from the Agriculture and Forestry Experiment Station cleared in the early 1900s and showing the degradation that became quite prominent just 10 years later. So in the context of the potential northward expansion of agriculture, this is a really critical area of study and much needed in order to better understand how structural changes will affect agricultural activities going into the future and vice versa. So with that, I'm going to hand it off to my co-presenter, Melissa, and thank you for your time.
Thank you, Glenna. So I will be covering the kind of permafrost aspects of this talk. I know this is the Permafrost Collaboration meeting, but just in case there's people in the audience who are less familiar with permafrost, or if anybody needs a refresher, I'll just provide a brief overview. So permafrost is any earth surface material that remains at or below 0 degrees for at least 2 consecutive years. So you can think of permafrost as behaving similar to a glacier, whereas a glacier needs more snow accumulation in the winter than ice melt in the summer in order to exist. It's the same thing for permafrost. We need greater ground cooling than ground warming throughout the year for it to be maintained. And about 24% of the Northern Hemisphere falls within area of permafrost. Here's a map showing the lateral continuity of permafrost. So the purple is showing continuous permafrost, where permafrost is present pretty much everywhere. It's laterally continuous, with a few exceptions in areas such as under deep lakes. And as you move more south and you go towards the discontinuous, sporadic, and isolated permafrost zones, you'll have areas with permafrost surrounded by areas of unfrozen ground. And of course, the more south you go, you'll eventually get to an area where there's no more permafrost. What is critical to kind of understand with permafrost is that permafrost is different everywhere. And one of the things that is driving this variability is ground ice content. So here's an example of a map, Brown et al., showing areas of low, medium, and high ground ice content. And just examples of what this may look like in the field. Here below, you see this is an example of ice poor permafrost. There's no ground ice visibly present. Whereas you can see up here, you see this is an ice wedge, which is roughly about 100% ice, just below the active layer that thaws every summer and is ice-free. And so taking into account this variability, how these types of permafrost is going to thaw, the response will differ. And to really show this, prepared a short video. So this is a video that my husband and I put together in our kitchen last winter. This is on our kitchen countertop. So we have 3 permafrost cores, one with high ground ice content, moderate and low ground ice content. And we left this overnight. and it took a photo every single 10 minutes. And you'll see, as the video will go, you'll see the responses as these cores thaw. So as you can see, the difference was quite variable. If you're looking at the low ground ice content, you'd really have to measure ground temperature to see if it was really still permafrost or not. Whereas once you get into the really high ground ice content, it really just turns into a slurry of sediments and water. And if you can imagine this occurring in your agricultural field, this will have a great impact on surface water and also impacts to crops and plants in people's fields. And so also, when the ground ice is present and intact, it occupies a volume within the ground column. And when that ground ice melts, your land surface will subside and you'll get these really big topographic differences. Here's an example from the Fairbanks experimental station. This is an image taken in 1939. And in 1932, this ground surface was perfectly level. So in about 6 years, quite these dramatic topographic changes occurred. And just examples of kind of ground ice that's possible within the Fairbanks area, and these types of ground ice are quite common throughout the Arctic. These are ice wedge exposures from the Krell Permafrost Tunnel located just outside of Fairbanks. And as you can see, here's people for scale. So the possibility of ground ice accumulations can be quite significant. And so looking for our Permafrost Grown Project, most of our field sites are focused on the greater Fairbanks area. Here's a map of the greater Fairbanks area. And you can see there's three kind of made ground ice classes. You have the lower ground ice content found here in the river valley. Then you have moderate ground ice. And then you have the higher ground ice content that tends to be found on north-facing slopes and in low-lying area with spruce trees, spruce forests. And then we also have kind of more satellite complementary sites in areas such as Bethel and Anaktuvuk Pass. And we are also collaborating with the Melenkov Permafrost Institute in Yakutsk, Russia, to also do a knowledge exchange with researchers there, because agriculture in that area is also seeing great change driven by permafrost degradation. And also all the field sites that you can see here on the map, these are all of the farmers that we're collaborating with on our project. It is their farms are our research sites, and we are working collaboratively with our farmers to, we've been working with them since the very beginning of proposal developments to develop research questions together and to tackle kind of to learn mitigation strategies. So when people do have land that has permafrost, they can have strategies that they can do to continue cultivation. And so as there's a range of permafrost types kind of throughout Alaska and Fairbanks and areas of the Arctic, agricultural activities also vary. And the way that agricultural activities and permafrost also vary. And so we have kind of three main types of agricultural activities in our project. Kind of have kind of vegetable crops, can be annual or perennial. And these might interact differently with permafrost, as say, for example, you're physically planting and harvesting your plants seasonally, but this could also potentially provide opportunities of modifying your strategy or your placement or your crop types. We also have peonies, which is Alaska's only agricultural export crop. And peonies differ because it takes between 3 to 5 years for the rootstock to actually start producing flowers. And so this could be potentially problematic, because if you plant all your peonies roots in a field with ice-rich permafrost, it's possible that this can kill your peonies plants before you get any kind of investment return on the plants that you purchase. And then also we have sites with livestock, and livestock is interesting. Some studies have showed that actually animals provide a cooling effect in the wintertime through snow trampling. And so these are some of the things that we'll be studying in this project. And so I'm going to continue with the permafrost. So our team has developed kind of 4 general permafrost degradation scenarios, and I'm going to go through these one by one and provide examples of sites. So type 1 is really ice poor permafrost. So if you remove the surface vegetation and the organic layer, you have the permafrost table, which is this hash line. And then you have the dotted kind of area showing ice poor permafrost. And as you can see, as your permafrost is thawing, it's going below the surface of the ground, you're not getting any subsidence, right? Because you don't have ground ice in this type of permafrost. So probably from an agricultural perspective, this is probably an ideal type of permafrost to be cultivating on. An example of a site that we have as part of our project is a new farm that went into production last year. This is the field that they established. You can see that there's still some piles of trees and vegetations from clearing. And they actually built a really large root cellar with this 60,000 pound root cellar capacity. And as they were excavating for the root cellar, they encountered frozen ground at about 6 feet depth, but they didn't encounter any ground ice. Second type of permafrost, it could be slightly more ice rich. You might have ice lenses kind of near the surface that as your permafrost thaws and your ground ice melts can contribute and cause some land surface subsidence. But again, this is probably likely manageable kind of through time while you're cultivating. And an example of this type of permafrost in our study, we have a peonies farm. And this peonies farm is located kind of an area of low ground ice content. And they have about 6 different fields of peonies. And this field, all these peonies plants were planted in the same day. However, there's this one back corner over here where the peonies plants are noticeably smaller. They produce less flowers. And just on the outside, kind of over here where the path is, there's a little bit of subsidence that has been observed. So one of the things we're going to do in this project is really look at the permafrost conditions happening kind of at that corner of the field to understand how it's impacting peonies growth. And then third, going on to more ice-rich permafrost, so you might have the presence of ice wedges, and you might have to start really doing potentially some excavation where you're infilling some areas where there's land surface subsidence to try to level it out, and where this could cause some thaw and some needing to pivot to new strategies, such as, for example, changing what you plant or kind of how you do things. We think that this type of permafrost probably still manage it okay and still be successful. And an example of this kind of farm is Iris's farm, and I'll let her kind of talk about her experience in just a second. And then finally, our last kind of permafrost type is really the really ice-rich permafrost, as for example, permafrost with syngenetic ice wedges. So these are these really continuous bodies of ice that is found typically in Yedema permafrost that is present in Alaska and Siberia. And with this, you might have so much ground ice, and if it's continuously, the permafrost is thawing, the ground ice is continuously melting, it might happen that you can't quite keep up with it if you don't have any management strategies, and this might lead to field abandonment. And really our goal with this project is really to understand this system and also develop strategies that if someone has permafrost in their field, to try to prevent field abandonment as much as possible. We do have a field in our study that was abandoned. This is the peonies farm that was, the land was cleared in 2001 and went into production in 2002. And about 2014, really signs of degradation started to occur. And the field was abandoned in 2019. This farm is still in production, but the peonies plants have been moved to a different field. And we've measured about 1.3 meters of subsidence between 2010 and 2021 using LiDAR and a UAV digital surface model differencing. And with that, I will hand it off to Iris to talk about her experiences.
Thanks, Melissa. My name is Iris Sutton. And first, a little information. I worked for a farm, a larger farm in Fairbanks for about 5 years, called basically Basil, and learned my farming experience mostly in that situation. And we had been looking for land to have our own farm at that point. In 2010, we bought this land, and it was 10 acres. We cleared about an acre of it. And as you can see, it's fairly flat. We used a bulldozer just to clear the very top rooty willows and alders. And then we pushed them up into a pile and for burning. And that was in 2011. We bought it in 2010, and then this is 2011. Just as to kind of explain my reason for farming, mostly I wanted to work from home so my kids could be with me, and that's the main reason. But I love growing things, and I'd always grown like enough for us to have food in the summer, and I wanted to do it on a larger scale. And then I really like local healthy food for our family and for the community. And I love building the community atmosphere and inviting people to my farm and including them in its production. My main goals in farming, as far as the growing things goes, is I really wanted to have a farm that didn't use chemical fertilizers. I really wanted it to be organic. I wanted my kids to be able to eat things out of the garden without me wondering what they were eating. And I wanted the impact on the environment to be minimal too. This is my son Zalix. He's holding a frog. In the last 5 years, frogs have just seemed to have exploded in our garden. We see them every day, and I take that as a good sign. I don't know. This is my daughter Hazel. She has grown up on a farm. She's 11 now. So when I was working for Gretchen, she was with me some of the time, and now she's at our farm. She understands plants more than I do and can explain everything, and I think that is valuable. Here is our farm, and I'm going to explain just a little bit about it. This is the main growing area. There's a fence here. The driveway, this is the driveway that goes up to our house. And on this side over here, there's a road. You can't see it, but there's a little section of the natural plants, alders and willows that were covering the whole area when we bought it, here between the road. And so I guess some of the things that have come up that have been challenges, or in some ways good things too, is that it's south facing. It has the road, which gives it a lot of sunlight, which really helps, but it also has had a lot of, the ground has sunk in places. When we cleared it, this was the low area, and we kind of pushed it up to make a pond as an alternative or emergency water source. And a few years after clearing the land, this section here kind of turned into a creek in one of our falls that was very rainy. So now, for most of the summer, we have a creek running right through here. And this is a bridge that we use to cross the creek now to run to get the tiller from one side to the other, or the wheelbarrow or anything like that. So that was a big change, I would say, in the first couple of years of farming. Here's our greenhouse. We were moving it every year with the idea that maybe it wouldn't have as much of an effect on the ground temperature, but it's big and hard to move. So it stayed there for a few years. And then over here, this part, you can see I put perennials in here, and my intent is that they'll be there for a few years, 3 or 4, and then I will move them to another section. We've also put perennials in here along where it has, the creek has formed, mostly so I don't have to till that area as much. And over here, this is where I usually plant potatoes. It doesn't do as well growing other things, so I've put potatoes in there. And as you can see at the bottom here, there was a big sinking area that just has come up in the past 3 or 4 years. And then up here in the past 2 years, it's just started to sink as well. So my potato section has gotten smaller, and I've started to grow some potatoes down here as well. I use a hoop row to grow things that like it a little warmer, like cucumbers and beans and basil. And then I use IRT plastic, which you can see here, for some of the things to keep the moisture in and to heat the soil a little bit for things that like it a little warmer. And then there are perennial trees back here. I did lose some of them in this area over the last couple of years when it sunk. Let's see, I have goats like I said, or like was mentioned, and they produce a lot of manure, which is great for the garden. And I also, as you can see this hose down here, I use catchment for water for most of the year. And so the IRT plastic really helps conserve that water. So I'm not using as much. Here you can see my daughter's putting in the IRT plastic in the spring. And I till up the rows. Not every year, but some years I get a big tractor in and we till the whole thing up. But lately I've started to just till up the sections that I need to use to put the plastic in or to plant a specific section. And leaving these areas untilled really reduces weeds, as well as it keeps the garden kind of more organized and easier, less work. So here, this section, you can see I left the IRT plastic in, and I'm probably replanting that section with it the way it is. All right, so here's some carrots. Carrots are one thing that grow really well at my farm. And every place that I've had that I've grown things in, I've learned that it's always a learning curve. Every place you grow vegetables grows things differently. Carrots grow well here. Beets, on the other hand, I've struggled with this last summer. I had some good beets, but it's always a challenge figuring out how and what they need in your specific area. Here's the garden in the fall. You can see the IRT plastic there. And greens are great. They always do great. Okay, these are strawberries. I have grown perennial strawberries. They're fairly low maintenance, and they're something that you don't have to till the soil every year for, which is easier for the farmer and easier, I think, on the land as far as warming the land, like reducing warming. So I probably will not expand strawberries just because they're a lot to pick and a lot to deal with once they're growing, but as far as them growing, it's fairly low maintenance. And then I wanted to talk just a little about pests. Permafrost is one challenge, but there's also voles, there's also root maggots, there's lots of other things that you're constantly trying to mitigate and deal with. So yeah, it's a constant challenge and a constant learning curve to grow in Fairbanks, for sure. And this is our production. I do have a small CSA. 10 shares go out to families in the area, and this is it set up for them to come pick up their vegetables. And you can see this kind of it shows just about what I produce. Everything from the root crops, carrots, potatoes, and beets, and all the way up to the brassicas, cabbage, cauliflower, broccoli, and then the greens too. So, and then we do a potato digging party every fall, and this is part of the community that I like to have. It's a big, potatoes are a reliable crop every year, and so I usually plant plenty of them. Thinking that if nothing else, we can eat potatoes, right? so I invite people, my daughter's friends come, and other people come to help dig potatoes and make a day of it. And here's some amazing vegetables. We always like to take pictures of the amazing vegetables. My son with a potato and Hazel with a lettuce that's bigger than her head.
Thanks so much, Iris. Yeah, so with that, I just wanted to kind of highlight some key point take-home messages that kind of the three of us collectively have come up together. And this could maybe spur future discussions during our hour. Just to kind of keep in mind that high latitude areas do have a rich and diverse food system, but do overall remain food insecure. Permafrost is different everywhere. And really, we need to consider the heterogeneity of social food infrastructure and permafrost systems when we're thinking of any potential agricultural expansion in the north. We also have to keep in mind that often what works in the south doesn't work in the north, and agriculture is a really great example of that, as we're still a lot of agricultural effort is just trying to do seasonal augmentation and also just, bring a market, getting infrastructure, that sort of thing. And then also it's really essential that high latitude residents and food producers must be included in research and planning efforts because they're really the people on the ground, they're the ones producing foods, they know what the issues are. And so it's really helpful for them to guide our research of what we should be targeting that can be helpful. And also they can also provide feedback and guidance of the results that we produce and share to the wider community. Is it digestible? Is it accessible? And just to make sure that the results that this project will produce will reach as many farmers as possible within Alaska and also other high latitude areas. And so with that, on behalf of the Permafrost Grown team, the research team at the University of Alaska Fairbanks, and all our farmer partners collaborating with us, our project is funded by the National Science Foundation, Navigating the New Arctic Program. And I'd like to thank everyone for attending and your interest, and we'll take any questions at this time. Thank you.
I just want to step in and say thank you, and people can either put questions in the chat or raise your hand or unmute yourself.
Okay. Meredith, do you prefer that we like unshare the screen, or is it best to keep our slides up?
You can unshare for now, and if anyone has a question about a specific slide, might go back.
Okay.
Yeah, I also wanted to say thank you. Those were 3 really great presentations, and I learned a lot, and kind of makes me hungry because some of those vegetables look so delicious. So nice that they also look pretty. Yeah, I hope people have some questions. You can put them in the chat if you're less comfortable speaking up. I also really like the permafrost experiment on your kitchen table. It's a wonderful visualization of different permafrost types and how it thaws and doesn't melt, just the ice melts. I thought that was really great.
Thank you. Thank you.
Yeah, you'll like what we call it, Christina. We call it Huhi-Hashli science.
Seriously?
Yeah.
Oh, for those of you that don't know, that's a Swiss word saying kitchen cupboard. And if I want to try to get someone to speak a Swiss word, I say that's what they need to try to pronounce. That's funny.
Yes, yeah, since the room's kind of quiet. Thanks, Christina, for stepping in for me. I'm sorry I'm on child duty today, so it's kind of hard for me to fully engage and interact. I guess a question for Iris. Iris?
Yes.
Just since you're kind of born and raised in kind of interior Alaska, Fairbanks area, how does how does this winter in Fairbanks compare to some of your past winters, just in terms of the amount of snowfall that's on the ground here, and then how might that affect the start of your growing season this next summer?
Yeah, there's a lot of snow this year. I think there's more than I remember having in many years. I think that it's going to make the garden very wet for a long time. Of course, a lot of it depends too on how our spring goes. If our spring is hot and dry, then it'll disappear pretty quick. If our spring, it rains a bunch in the spring, or it's very cool for a long time, I think that we're going to be pushing planting later because of all the snow. So I do spread ash, like wood ash, in my garden to melt the snow quicker because it tends to be a kind of a wetter area. Yeah, that helps too. But I think that snow load it's a big dependent on snow load, but it's also dependent on our spring weather.
Okay, cool. Thank you. Great presentation, by the way, Iris and Melissa and Glenna. Those neat transitions between the 3.
Maybe I can ask a question. I would be curious, how far north do people do agriculture? like Fairbanks is not even that north, and I wonder what's like the limits where it works. Do you know?
Sure.
Hi, that's a great question, and it's variable throughout the circumpolar north. So in Alaska, Fairbanks is kind of our northernmost region where there's regular agriculture production. However, there are sites. In fact, we're working with one producer at Anactuvic Pass, which is, do you remember what latitude they're at?
This is a continuous permafrost zone.
So
Yeah, it's quite a
up
bit
here,
further. Yeah.
yeah, up in the Brooks Range, and she uses season extension techniques. So she has a greenhouse and high tunnel. However, she is starting to grow more things outdoors, and that's actually something we're going to help do some trialing with her, and to kind of test that sort of new boundary, if you will. I also have worked with producers in the past through a program I taught called the Alaska Growers School, and we had producers in rural Alaska as far north as Barrow, and so yeah, there's and I will say people in some of these more rural regions, Unalakleet is the far northwest in Norton Sound. Places like this, folks are using season extension techniques, largely due to in order to protect plants from the wind, as well as the cooler temperatures. So you kind of see it sporadically. However, if you compare it to Scandinavian and Scandinavian countries and Northern Europe, just our climates are quite different, and so actually agricultural activities can happen quite a bit further north in terms of latitude than they can here in Alaska. That all said, Alaska is a huge state, and we have many climatic zones here. And the Kenai Peninsula, which is about 600, about 1,000 kilometers south of us, that's the high tunnel capital of, I think, of the world at this point. So in terms of high tunnel density, that is the place where they are really used more than anywhere else. And people are having successes from not just your everyday agricultural crops, like the root vegetables and things, but people are growing berries, they're growing lemongrass, they're growing fruit trees. And this last summer I visited a farmer who had plums and pears and peaches and apples and all kinds of things growing in his high tunnels. So really there's a huge agricultural potential in the state. It just is really dependent region by region. So I don't know if that answers your question.
Yeah, that helps a lot, because
yeah.
I live in Flagstaff, where it's Arizona, but it's kind of high elevation, so we end up with frost sometimes in June, and that really limits the potential for growing things. And I wonder I think sometimes in Fairbanks you can start earlier than you can in Flagstaff, which is funny. I don't know. Is there not that much of a frost expectation past a certain date? I honestly don't know.
Iris can tell you, and I'll tell you, both of us having grown up here and been on in gardening families, there's no such thing as a hard and fast date. I mean, it can frost in May, and that can be the end of it, or it can frost in June, July, and August. It really depends on the microclimate with which you find yourself trying to farm or garden. There's a general rule of thumb that says by June 1st, it's safe to plant things in the ground. Again, dependent by year. That seems to be changing a bit. People are saying more and more so, like, oh, Memorial Day weekend, or even like, May 25th. Again, depending on your slope, where you're located, your elevation, things like that. And this is for Fairbanks in particular. I also oversee variety trials down in Palmer in the Mat-Su region, and they're easily a couple weeks ahead of us. But their growing season is overall cooler and wetter. And so even though they might have a slightly longer season, what they're able to produce, for example, I can get sweet corn to produce and mature here, whereas they cannot down there. And likewise, there's some longer season varieties that we're actually having more success with here in Fairbanks, just because of our overall heat throughout the season, but also because of our long photo periods. So we have long days, right? And that really contributes to plant maturity, even though we tend to hit senescence or the dying off of our plants pretty abruptly sometime in August. And if we're lucky, we can eke some things into September. Yeah, but in your case, I think some season extension techniques would be really useful. You know, if you did some low hoops with some kind of frost protecting cloth that's often called remay, you'd probably be able to avoid, you know, a killing frost on your plants in June.
Cool, thank you.
Great.
Are
Yeah.
there any other questions?
There was a comment in the chat, Christina, from LJ, just saying that Jack Rekoff grows potatoes in Wiseman.
Yeah.
I don't know where Wiseman is, but I'm guessing it's far north.
If you know where Coldfoot is as you're driving up the Dalton Highway,
I do,
it's
yeah.
just a little bit beyond Coldfoot.
Okay, cool.
And there's a
Great.
long history of, you know, gold miners, you know, all kinds of people, including Alaska Native villages, who have these what are typically termed a pure subsistence gardens. So there's definitely an ingenuity and pioneering or creative spirit here when it comes to trying to make a go of things. So you'll see places all over the state where someone has tried to plant something. And then I will just mention, you know, in terms of microclimates and the, you know, the immediate environmental conditions, there is a place called Pilgrim Hot Springs up near Nome. And they're actually able to grow things year round, even having some success with root crops grown under the snow because it's geothermally heated. And we do have some greenhouses here that are using geothermal heat to continue production throughout the year. So we have pockets of places where I would say there's a lot of potential. Alaska, one of our biggest challenges historically and continuing through now is that we really are just limited in many ways by our infrastructure here. So whether or not these areas that have like the geothermal energy are able to get materials in to that area in order to, you know, build a greenhouse or have soil amendments that they need in order to, you know, enrich their soils, seeds, things like that. You know, it costs a lot of money, it takes a lot of time. So that's one limitation. And then likewise, if you start having a really large scale production, how do you get that product out to market? You know, so if there's not a local market, then it's got to get distributed somewhere. So yeah, just the sheer scale and then, you know, population and infrastructure in our state really make our agricultural, you know, scene quite unique and poses some unique challenges that really aren't experienced in other places that might have some of the same conditions.
Yeah, I can see that.
Yeah, I hadn't thought about having to move a greenhouse also to keep the permafrost from melting too much. That was really interesting to me.
I have a question, maybe. So it's Matthias.
Hi.
From Germany. Hey, I have a question. Maybe just before a comment, maybe interesting to know that the Russians, for instance, around Yakuts, they use special bred wheat, which is growing very fast during the phenological phase, just in 3 months. So it's maybe quite interesting to know. And then my question is, you already said a little bit about that. So what is the limitation of large production field? So is this just the economical reason, or is it also the ecological reason? So because of the permafrost, because it's very hard to mechanize such fields and whatever. So what's the?
Yeah, it's I would say it's an amalgam of all of those things. One of the biggest kind of challenges that's often pointed to, and when we've had like an agronomist come, so an economist with a particular focus in agriculture, and do a statewide report, you know, one of the biggest things they commented on, reported back, was the infrastructure issue. Our state is really disconnected in terms of our road system, our rail system, and many communities are only available by small plane and boat. And so it limits the number of places within the state that are, you know, ecologically viable, climatically viable, like all of these things, and then also have access to infrastructure. Those are kind of the big ones. Some of the early agriculture, some of those photos in black and white that I shared earlier, some of those were from the Matanuska area. And so the other thing that we're seeing is a loss of the already established and very productive croplands in Alaska. So the Matanuska Valley was probably Alaska's biggest, most fertile region. And now it's become, it's subject to urbanization because it's really a bedroom community that's been in a huge state of growth for Alaska's largest city, Anchorage. So we're losing cropland in areas like that. We're gaining some agricultural lands in other places that have been opened up over the years by these big agricultural projects, they call them, that are basically state lands released for sale. But that's another history lesson for another day. And so that's had varying success and limited success, I'll say that. So yeah, those are some of the bigger challenges. But then yeah, cost of shipping for things, local amendments for soil products that can be integrated into the growing season, and then market, access to market. So you have to get things in and you have to get them out if you don't have an immediate market. And that's where things like CSAs, so Iris had talked about her community shared agriculture. That's a model that's grown all over the world, but Alaska's had more and more success with that, where small scale farmers are making their products available for people in their immediate community. And that seems to work fairly well for Alaska's model, but it doesn't necessarily contribute to a large scale commercial market that might have more export. There's definitely potential. There's a few large scale farms that are growing carrots and potatoes and have storage facilities that I think can hold like 60 acres worth of carrots. So that's like thousands and thousands of tons of carrots. And they are like approved vendors to our local groceries here, but it's again still not necessarily economically viable to then ship those products out of Alaska when you consider the overall cost of that transport and the carbon footprint of that, really. So yeah, there's a lot to it. I don't know, Iris, do you have any other thoughts about what makes it go or not go?
I think that there's just a lot of variables, from everything from being able to produce things and then store them. I think storing is a hard thing here because there's not large scale commercial storage, and if we grow carrots and potatoes and have them all available in August and September, but people don't want them, they don't want to buy their whole year's supply of carrots and potatoes in September. They want to be able to buy them all year. And so until there's that storage possibility, it's going to be hard for farmers to be able to do that. I think carrots and potatoes are crops that do really well here, and probably cabbage and some others too, that store really well. And if there was the facility to store those in a way that they stayed fresh, which root cellars do great. I have a root cellar and we eat our carrots all year, even into June, we're eating last year's carrots. And they taste way better than any carrots you'd buy at the grocery store. But that large scale storage is a big challenge for Fairbanks and Alaska in general, I think.
Yeah, well, thank you very much. We are at the top of the hour, and I wanted to say thank you again to our speakers. I'm sure if you have any further questions, you can contact them through email. And I hope you have a good day. Thank you again.
Thank you.
Thank you. Bye.
Yeah, great job. Thank you.